Oh, yeah. Kindergarten too.
No, I think the very scenario.
I did 101. I got So why are you
This would be my
he would be saying.
Yeah, I just got but I like to talk to her more as like sometimes person on person about like
All right, do we have these rules copied down? Okay, so each of these rules, okay, allows me to rotate an object counterclockwise. Okay, that's important. Okay, counterclockwise about the origin. Okay, the first one, if I switch my coordinates and take the opposite of the y, that's a 90-degree rotation about the origin. Right, so we're taking a figure, okay, and it's like we attach a line from each point to the origin, and we just rotate that 90 degrees. Okay, same thing for the 180. Attach a line from each point to the origin and rotate that line 180 degrees. Same thing for 270. Okay. Now, another note, right, and we'll look at some of these things probably tomorrow. A 90 degree counterclockwise rotation. So if I'm going 90 degrees this way, that would be the same as if I went 270 degrees clockwise. Okay? So a 90 degree counterclockwise rotation is the same as a 270 degree rotation clockwise. Okay? 90 degrees is basically just 1/4 of the coordinate plane. Right? So it's saying, well, if I go 1/4 this way, that's the same as going 3/4 the other way. What? Yeah, that would be true. A 450 degree rotation would be the same as a 90 degree rotation. Yeah, that's absolutely true. So then we could also say a 270 degree counterclockwise rotation is the same as a 90 degree clockwise rotation.
So if we're going clockwise or counterclockwise, are always going to be in the same position if it gets into that quadrant.
We're just going to use these three rules and assume that it's counterclockwise. But if something asks you to go 90 degrees clockwise, we just need to know to use this rule. It's the same as the 270. Okay. Other questions so far? When we're looking at coordinates, yeah. So for example, if we look at the point 1, 2, and and I want to rotate that 90 degrees counterclockwise. That would be -2, 1. Yep. Switch them and take the opposite of what the y coordinate was.
You know, like, when C is C1, because now it's like, it's not just like moved over. How do you know how much to turn itself that much?
So when we do a couple examples here, I'll show you exactly what's happening. The important part is going to be this rule, because the geometry part will be really difficult to use in practice, but it's a good way to double check yourself to make sure you're right. So I will answer that question when we do an example here. Okay. Any other questions before we look at some examples? All right, then let's look at number 1 together. Okay, so for rotations, okay, I think it's easier to first write down our new points. Okay, so if I'm going, so the rule for 90 degrees counterclockwise was flip them and take the opposite of what the y was, right? So if I take my A, which was 2, 7, I flip them and take the opposite of the first one, I'm going to be at -7, 2. If I take my B, flip them, and take the opposite of what the y was, and then same for C, flip them, and take the opposite of the first one. Okay, so let's graph both of these. Let's graph our original points and our new points to see what's actually happening here. So point 2, 5, 6, 7. That's A. B is at 6, 5. C is at 4, 1. So here is my original triangle. So now my new triangle is going to be at -7, 2, -5, 6, A prime, B prime, and then -1, 4. Okay, so here is where this figure ends up if I take it and rotate it 90 degrees about the origin. So what's happening? Okay, if I draw a line from each point to the origin, that's straight, and then I also connect, it makes a perfect 90-degree angle. Okay? And these are the exact same length. Okay?
I see how if you just switch them out of that work, I didn't think that would work every time.
It does. Okay, so if I were to do that with every single point, right? If I connected A here and then here, I would get a perfect right angle. Same thing with B. If I drew a line from B to the origin, then to B prime, I would get a perfect right angle. And each of these lengths would be exactly the same. Okay, so that's what's happening when we're rotating 90 degrees. Okay? If I'm rotating 180, what's going to happen? Obviously, this won't be a right angle. It'll be a straight line, right? It'll be a perfect straight line where each side through the origin is exactly the same length. Okay. Questions? Do we want to do another one together, or you guys think you can try some? Try some? All right. Let's go ahead and try some here. Yeah, no, you're probably not done with all these. That's perfectly fine. Okay, but let's check our answers here. It's kind of small. Let's see if we can zoom in a little bit. Okay. How did we do here? Okay, any questions on something like this? There's one other random thing that I want to do here that's not on your notes. You can add this in somewhere. It's something real quick. So no questions about any of these? Alright, what if I don't know. Look at a flower. No, I don't want to do that many petals. How about just 1, 2. How about assume those are all the same size. Alright. Okay. We've got this flower, and let's assume they're all the petals are symmetric and all the same size here. And I say, we've got some point here, we've got a bug on this petal, and we want to figure out the angle of rotation to get up here. How would I figure that out? How would I figure out how much I would have to rotate this flower to get up there? Exactly. Right? We know a full rotation would be 360 degrees, right? So there are 5 petals that are exactly the same size, right? They're symmetric, so I could take 360 divided by 5 to figure out how the rotation it would take to get from one petal to the next. So what is 360 divided by 5? 72? I hope that's right. So if I'm going from here to here, then how much of a rotation would that be?
208, something like that. No, 144.
144, right? 72 times 2 to go from here to here. Right? 72 times 2 would be 144. What's that? Sorry, my drawing skills aren't great.
It's like, petals, but in between. So how do you know it's 2 and 3? Because I thought it was 3.
So yeah, we want to think about the spaces, right? So to get from here to here, 72 degree angle.
Oh, I see.
Then to get from here to here would be another 72 degree angle. So that total rotation would be 144. Okay. So what if I give you about that's kind of close. Okay, let's assume this is a regular octagon. Okay, perfect octagon. Yeah.
You can't draw. You can draw flowers. You can't draw flowers.
Yeah, I'm a geometry teacher.
Well, octagons are straight lines. It's harder to draw.
So, how much of a rotation would it take to go from one corner to, I don't know, to this corner over here? How much would I have to rotate this figure?
8 divided by 360 times 1.
360 divided by 8, then times 3, right? So what's 360 divided by 8? 40? No, 90.
That is a number.
45. 45. Yeah. 90 divided by 2 is 45. So then I would go 1, 2, 3 of those. It's a good point. I didn't specify which direction to go. Okay, so if I asked you to go this way, which would be clockwise, it would be times 3. But if we asked you to go counterclockwise, it'd be times 5. Okay, so if we want to go clockwise, 25 times. Yeah, you're right. Yeah, sorry. Counterclockwise. Yeah.
They're going to be all but
Figure it out. You do 360 minus 135 to get the other one.